All right, guys, in this video, we're going to be looking at a multiple choice and free response question over collision model. In this first one, this multiple choice question, we're given two steps. One is slow, one is fast. The reaction is carried out at constant temperature inside a rigid container. Based on this mechanism, which of the following is the most likely reason for different rates of step 1 and step 2? Okay, in step 1, it's a slow step, and step 2 is a fast step. In the slow step, that means it's going to be taking longer for the reaction to happen. It has the rate is a lot slower, whereas step 2, if it's going fast, the rate's going to be going a lot faster. So we're trying to figure out why is step 2 going faster than step 1, and there's got to be one of these reasons to explain that. In A, the only factor determining the rate of step 2 is the orientation of HI and ICl polar molecules during a collision, but it's negligible when H2 and ICl molecules collide. That's not true. Okay, orientation always plays a factor. And how they collide is a big factor. Everything matters about orientation, not one versus the other, negligible, so that's not right. B, the amount of energy required for a successful collision between H2 and ICl is greater than the amount of energy required for a successful collision between HI and ICl. That is definitely very possible. It is probably the right answer, and it does accurately explain. They're saying that these two molecules will have lower activation energy or lower amount of energy required to make a successful reaction than this one. This one would be higher, which makes sense since it's the slower step. So that is a very probable answer. C says the fraction of molecules with enough energy to overcome the activation barrier is lower for HI and ICl than for H2 and ICl. This one doesn't really make that much sense, and it isn't the right answer, like the fraction of molecules with enough energy. It's either going to be higher energy or lower energy for one than the other. It's not like a part of it's going to explain for that. So no, C doesn't really make sense and doesn't fully answer the question. And then D, the frequency of collisions between H2 and ICl is greater than the frequency of collision between HI and ICl. Once again, this also doesn't account for the fact. It's also not true since we're at a constant temperature inside the rigid container. They're going to be having about the same amount of collisions between the two of them. So D doesn't answer the question. B is ultimately the right answer. And it explains why this is a fast and this is a slow step, is with those successful energies between the two of them. Okay, so that's B, or that's the multiple choice question. This is a free response question, and it doesn't have the reactions for this this question, but we don't really need it to answer these questions. We can answer this very generically. So the experiment is repeated at a higher temperature. It doesn't matter what the experiment was. Explain the effect, if any, that higher temperatures has on collisions between reactant particles. I'm going to answer it underneath here in two spots. So here I'll answer it for part I. So higher temperatures, what is it going to do? There's two things it can do. It can increase the number of collisions by having higher temperatures. Or you can talk about how the collisions will have more energy. Collisions with more energy. So these are your two possible choices. You only have to use one of them as your example to make an explanation. But at higher temperatures, particles will be moving faster, so there'll be an increase in the number of collisions. And at higher temperatures, they'll be colliding with more energy because they're moving faster. So both of those play a big factor in the collision model in figuring out how fast reactions will happen. So you have to use one of these two to create your explanation and what effect it will have on collisions between reactant particles. And then part 2, identify the effect, if any, that higher temperature has on rate constant. Explain your reasoning. Okay, I'm going to first answer the question, then I'll explain what it is or why that happens. So at higher temperatures, the rate constant is going to go up. It's going to increase. Okay, and I'm going to use the rate law to explain why. So here's rate that is equal to K times the concentration of something times whatever concentration, whatever the rate law is, right? Well, based on the rate law equation, the rate is directly proportional to the rate constant. Remember, the rate constant is K, rate constant, whatever. So if the rate is going to increase, the rate constant has to also increase. The concentration is going to stay the same because we're not increasing the concentration. We're increasing temperature. If we increase temperature, we talked about it in part one, that the rate is going to increase. So if the rate increases, the rate constant has to also increase. So you can use the rate law as an explanation. So what I would do to answer this question, I would say by increasing temperature, we increase rate, and according to the rate law, the rate is proportional to the K, rate constant. So so K increases. Okay, something along those lines, talking about how temperature affects the rate, which according to the rate law, rate is proportional to the rate constant, so rate constant increases. Some form of writing that out should get you plenty or full points on those questions. Okay, hopefully that was helpful. Oops.